So this video is to model through the mathematical application parts of this Electricity Part 2 homework. If the mark scheme hasn't helped you, I hope that my modelling step by step will help. So in this question, so this was question 6, we're being told that we have got 20 seconds, that's time, and we've got 18 joules, that's the energy that's transferred. We're being asked to calculate the power. What is the power? Power is measured in a unit called the watt, and there is 1 mark available for that. That's why this is worth 4 marks. It's because you've got to recall an equation, substitute into an equation, find an answer and put a unit on it. So the unit mark I've already got just in thinking about the question. So power is the energy transferred per unit of time. It's the energy transferred per second, the rate of transferring energy. That's where that equation comes from. So the energy being transferred is 18 joules in the time of 20 seconds. So I need to do 18 divided by 20. So I've recalled, I'm substituting, and then when I work out the answer, I make that 0.9. So the power of the lamp would be 0.9 watts. And then in part 3 here, the potential difference across the lamp, we're told, the volts, the voltage or potential difference in standard units. The current, so we know V, we also know I in standard units of amps, and we're being asked to calculate the resistance, and if we look down here, they want that in the standard unit of ohms. So this is actually recalling an equation from part 1 of electricity, the year 10 work. This is Ohm's law, V is I times R, voltage is current times resistance. So the voltage or the potential difference is 4.2. The current is 0.19 and it's the resistance that we're trying to find. So of course you can use your triangle here if you want to. We're dividing both sides by 0.19 so that we get resistance on its own as the subject. That's 4.2 divided by 0.19. And when I put that in my calculator, I get 22.11 ohms rounded. So I might actually round that even more here. My final answer, I'm going to go for 22 ohms for a nice neat final answer. So if we have a quick look at this question, just in case you wanted a bit of extra help, we are told that we've got 230 volts here. So that's our potential difference. We are also told that the power is 2.6 kilowatts. So we need to convert that power into watts. Notice that straight away. So a kilowatt is 1,000 watts. So we've got 2.6 times 1,000 here, which is 2,600 watts. And we've got to calculate the current in the heater. So we know V, we know P, and we're being asked what I is. So the equation that we need to recall here is that power is current times voltage, and we're going to need to rearrange that equation, but I'm going to substitute into it first to make sure I get as many of these 3 marks as possible, even if I do make an error along the way. So the power, if I substitute that in first, 2,600, is equal to the current that I'm trying to work out, times by the potential difference of 230, sorry, I found it there, up there at the top. Therefore, if I divide both sides by 230, and of course you could do this with a triangle if you'd rather, these 230s cancel out, showing me that to work out the current I need to do 2,600 divided by 230, and I'm going to put the answer rounded to 1 decimal place, so that's 11.3 amps. And now to part B. Now in part B we're being told the power in watts, standard unit, and the current in amps, standard units. We're being asked first for one of the marks to recall an equation. So the equation that relates power, current and resistance. So that's power is I squared R. One of the equations we need to be able to recall and apply. So to calculate the resistance in the headlamp, we know the power is 55 watts. We know the current is 4.4, and we're going to have to square that before it's times by the resistance. So the first thing I'm going to do is find out what the square of 4.4 is, and it's 19.36. And then you could use your triangle if you wanted to. If you were making a triangle, then you would have the 55 in the top of your triangle, the 19.36 and the R down here, which means when you cover over the R, it's showing you to do 55 divided by 19.36, which is the same as the way I prefer to do it, which is the balance method. So these have cancelled, leaving me R is equal to 55 divided by 19.36, and that comes to 2.8409, which I'm going to round up to 2.8 ohms is the unit that resistance will be in for my final answer.